Here in this video, we will see a program for the linked list. And I start. You know, a C program starts with an header file stdio.h. Now, in this program, I will use malloc function, and this function malloc works under the header file stdlib.h. So I have to include that header file as well, stdlib.h. Now our main function starts. Here is the main function, you see, and this is the body of the main function. And as you see in the algorithm of the linked list, that this struct will contain two different things. A struct node is the user defined data type, and inside this the user may contain any types of data according to his or her wish. I here, since I have to make a linked list of integers, so I take the data of integer type. And linked list, as the name is linked list, this means that you see the data, all the data must be linked to each other. And you see a struct node, so to link the data we have to use the same, that is a struct node. And suppose this variable is a pointer, and this variable name is next. To show the to ensure the to take the data, the next data, so it is named accordingly. Now the user enters the data, so we have to see a message to the user that enter the data. So seeing this message, the user will enter a data, and suppose the name of this data, I have to declare that data, and suppose its name is element, or more clearly it should be integer. Okay, integer. And since the user will enter the data for the linked list, so we have to scan that value. And since it is of integer type, so the format specifier will be %d. And since the data are stored at an address, so ampersand, and here will be the variable name element. Okay, so far it is okay. Now we take three variables for this struct node. The first one, node star p, or it may be better if I take first. The second one, move, and the third one with name temp. These three variables. And I say, why am I taking these three? The first, in the linked list there will be all, here it is better at the place of temp, it is better to take new node. Its name, okay, I take the third one under the name new node. It is better to take the new node. And why am I taking these three? Remember, when I prepare a linked list, then obviously there will be many data in that list, and in that list this first will indicate the first node, always the first node. And you, when you add, suppose I placed 12 and beside 12 I am placing 24, so the first data is 12 but the last data is 24 in the linked list. Suppose there are three elements in the linked list and these are 12, 24 and 36. Then in this case as well the first is the same 12 but the last changes. Here the last data in the linked list is not 24 now, it is 36. For that, so the last data is changing. For that I have used this thing move, and here it is new node. This means that when I create a node, that node will be called new node, and the creation of new node will be done by the malloc function. So always remember the first, here first means the first node in the linked list, and the move means the last node attached in the linked list, and this new node means the node you create for the first time. Now I take a while loop. I take a while loop, and what will be the condition inside this? You know, there is always a condition inside the while loop when we use the while loop. I will write the condition later. First I write inside this. So the first thing you know is the creation of a node. So I here take this new node, I copy this new node, and here you know the malloc function will create, and you see this new node, a star new node is the variable node of this user defined data type, and you see that this is the same as you see here, and inside this there are two things you see under the blue background, and this thing is a struct node type. So the malloc function should create a struct node type things. So here I type a struct node star, and who will create this thing? The malloc function, and thereafter the size is declared. How many such struct node you need? If you need one, so there is no need to write one, because in multiplication one always exists. So I just type there size of size of, and here will be a struct node, a struct node. Okay, so this action creates a node. Now it is time, you know, you see this new node. This new node is of a struct node type, and here is the struct node, and inside this you see there are two types of variables, You can see here, one is the data and the other is the address, a pointer. So for the data, I type here. In this new node there are two types of things. So I here type accordingly new node two times. Okay, yes, two times. And the first, I here, for the abstract thing, when we use data, we use arrow. And you should think that why this is a pointer, because here I have taken three variables with asterisk. In all, you see there is asterisk, you see, in all. This is the part due to which I am taking here an arrow, and here will be new node. The data residing in the new node will now store the value of the element which is inserted by the user. Now the I have inserted the value for the data part. Now for the address part, I again use the same thing, this arrow, and here next, and this will be given for the time being null. Okay, so we have filled. First we created this node, the named new node, and after creation, this is the part of the code which is responsible for the creation, and thereafter creating that node, we filled the two parts, because here a struct node is containing two different things, and I have filled that two things with these two C statements that you see under the blue shadow. Now since this is the first node, this is the first node, so here it should be named first. So first equals to new node, and the linked list is ready, but it is containing only the only one data, but you should have to add many data into this. And also I said that earlier, when I declare these three variables, I said that first will be fixed for the first element. So since the last node changes, when you take 12 and 24, then the last will be 24. When you take 3, 12, 24, 36, then here the last is 36. So last is changing and the first remains constant all the time. 12, it is 12 in our example. So but when you have only one node, then the first and the last will be the same. Suppose you have a linked list of 12, only if this list has one data, then the first data is itself 12 and the last is the same 12. So here this move will be given the same node, that is the node you created and filled, and here so I copy and paste. So here for the first time, when you have a linked list of size 1, the move and the first will take the same thing. Now after that, the After that, for the second run, while is a loop. These things are under the body of this while loop, and a loop runs many time. For the next time, the value of this new node will change. The value of the new node will change. So because you for the second time you will enter different data, so this the new node created will take new data, so this first will change. So for that purpose I have to type this thing outside. This thing this thing this thing will be outside, should be outside. So I copy and paste here. I paste here. You should you should observe the reason why I did so. Now, since I copied a part of the while loop outside and pasted there. So there is now no need to write this thing, because corresponding to the first node the work is outside, and you see that work is here. This stands for the first node. Now here I have to give, since the first node is created, so the last node will, if you have a linked list of size 1, then the last node will be this new node, as well as the first node. If you have a linked list of size 1, then the first node and the last node will be the same. So I have to give I have to store this new node inside this move variable as well. So I and copy and I paste the same thing here. So the work for the first node is complete. This is for the first node. After the first node, under the while loop, a new node will again be created for the second node, and in that we will store the data, but in that we will store the next data. So I have to show a message to the user again, and for that I copy this part and I paste here. Since the user sees this message, so he will be prompted to enter a data, and for that the data inserted by the user should be scanned. So again, for that purpose I copy this part and paste here. See the steps carefully, it's very easy if you observe carefully. Now here, since you see here, move refers to the first node, because here it is first node, so we have to attach the next node in the next part of this move. So here there will be an arrow, here will be next, and that next must be given this value, this variable. So I copy this and paste here. I paste it. Now after attaching, this is the part where I have attached a new node to the linked list. Since this part is attached, so this new node is now the last node. So this move should store this new node, that is the last node now. So after storing, this move again refers to the last node. Now this continues, and one by one all the data entered by the user get attached to the linked list, and this continues for infinite number of times. But we in particular in a daily life we deal with finite numbers. Suppose you have to make a list of books, then obviously you have finite number of books to arrange. For that, this linked list should end. And suppose you are dealing with percentage of different students. I have not written the condition. Here you see I have to write, and the condition depends upon which work you do. Suppose I am dealing with the percentage of students, so percentage obtained by a student cannot be negative. So to terminate this linked list, I use a negative number, and first negative integer is -1, so I place here -1, but one can type here -2. So I type here -1, and here the condition will be accordingly new here, because we are inserting data in the new node. So I copy this part and here I paste, and the data inside this new node should not be negative. So this should not be, suppose -1, as I said that you can take any negative value. Here is the okay. So whenever you enter a negative number, that number -1, then the attaching or the process of attaching new node to the list terminates. And now by this part the linked list will be created, but it will remain in the computer's memory. And to show the linked list to the viewers, one should use printf function with a while loop, because a linked list contains many elements, and for that this move must be changed, and it should store the values in the first, and thereafter we use the while loop. Here I use the while loop once again, but this time to show the elements in the linked list. And here move the data inside the next inside the move should not be equals to null. If it is null, that this means that the linked list we have reached at the end of the linked list. And here I use the printf function inside this to show the linked list. So here will be the printf function, and here I type %d as the data are integers type. Here \t to keep the integers of the linked list at a type distance, and here after that I type move the data residing in the move. By this action we will see the data in the linked list, and as we have to see all the data from the first node to the last, so this move should be moved. For that, move is made to point the next one, that is move the link residing in the next. And now I think our program is complete. And but here in the main function at the end we use this return key and 0. So it is complete. Let us run this program. Here and it says save the program. So I save this under the name linked list. Now it runs. Okay, it says something is wrong. Yes, you see here, I show you. Here you see, here line number 5. In 5, line number 5, element was not declared. And obviously this is true. In 5 I have declared an integer, but I have typed element. You see, I typed element. So due to this reason this is showing an error. So I change this and I type accordingly element. Okay, I done that. Now I run it again. Now it is running. It is showing no error, and I magnify. See here, yes, it is saying enter the data. So I first, you can type any data. Okay, I take some other data, suppose it is 28, and thereafter enter. I press the key enter, and again it is saying enter the data, because a linked list may contain any number of data according to the thought of user. Now I enter 58. It is saying again that what is the next data. These all data will be attached to the linked list, and the third one I can take any number. Again it is saying enter the data 78, 45, 33. So far you see that we have entered 1, 2, 3, 5, 6, 7 data, and in this way you can attach, you can insert in the linked list any number of data. So now the user may think that now I don't want any more number to attach with the linked list. I want to terminate this, and for that, remember, I have taken a negative number. If you and that negative number was -1. If I enter -1, then this linked list gets terminated. I show you. Here it says enter the data. Now I place here -1, and in the program as well, the integer -1 was to terminate this program. Now no more data will be attached, and now I press the key enter, and you see, yes, now it is showing. Here you see, this is the output. It is the data you have attached. It is the linked list. You see, first you inserted a 28, and the same you see here. Second was 58, so you see the same 58 here. The third one was 89 here, 78, 45, 33, but there is no -1, because the purpose of -1 was to terminate the linked list. Okay, so these numbers under the white background is make a linked list, and I think now you have understood the various parts of this program. If you are even not clear, then I request you again that you should see the algorithm that was in the previous video again, and after that see this program again. You will clearly understand all the parts. I hope so. And now I show the entire program once again. Yes, here is the first part of this program. Here is the second part of this program, and this is the last part of the program. If you have any doubt in any line, you may ask in the typing a text in the comment box of this video. Now I have to show you one more thing, and that thing is, here you see this declaration. You see this declaration, you see, and this declaration is inside the body of the main function. Now you may think, what is the body of main function? I show you. Here is the main function, and after that this curly bracket starts, and this all thing from this to, you see, up to return 0. These all things are inside the main function. So obviously this part is also inside the main function. Inside the main function, you may say inside a function. If you declare anything inside a function, then it is called local declaration, and I can cut this part, and I can declare that part outside the main function. You see, now the declaration is under the header file, below the header file, not under the header file, below the header files. There are two header files, but this part is now not under the influence of any function, and such declaration is called global declaration. Global declaration means this declaration can be accessed by any function, whether it be a main function or other function, and you will get the same result. But the benefit of such a declaration is that this declaration can be accessed by any function. So we should learn this global declaration, because in the next programs I will use such a declaration frequently. Okay. Now one may think that whether it will give the same output or not. I show you this will give the same output as was in the past output, but the numbers, the data taken by me in the past output is not in my mind. So I take different data here, and suppose it is, I remember but not all the numbers. I remember that the first was 28, the second was 58, and after that I don't remember. So I am taking randomly any numbers. Suppose it is 67, 90, 43, 98, 44, and you may take any number according to your wish. I have taken so far 8 numbers, 8 data. Now I want to terminate this program. For that I take -1, and now I press the key enter, and as you see the same 28, 28, 58, 58, 67, 67, 90, 90, 43, 43, 98, 98, 444, 444, and the last one is 99,877, and the same you see here. So these data under the white background is a linked list. So by both, whether you declare locally or you declare globally, you are getting the same output. But in this program there is no effect whether you use locally or globally, because in this program there is only one function. That function is main function. But to use globally is more beneficial. When we use different function, we use other function in addition to this main function. So we should learn how to declare globally. Okay, thanks for this video. Now in the next video we will work about this linked list and about its characteristics. Okay, thanks.